Suppose we're interested in approximating the function 3 to the x cubed at values near 1. Determine the third Taylor polynomial for this function. So we've got our function. Okay, we know the center. So what we need to do is start working out derivatives of our function evaluated at this center. Okay, so we'll start with the 0th derivative. Okay, evaluated at 1, well, that's just going to be 3 to the 1 cubed, or 3. So not really a whole lot to do there. To derive this, we just use the chain rule. And evaluating at 1, well, anything to the power 1, or anything times 1, is just itself. So really we've got 3 times 3, 9 for our next value. Okay, how about the second derivative? Here we're going to have to use the product rule. The 2 comes down, we get 6x. Okay, and again, we can really ignore the to the powers of x and to the multiplication of x, because these are all going to be 1s. So we get 3 times 9, 27, plus 3 times 6, 18, 45. Now our third derivative here, something we could do before that is just combine this, so we only have to do one product rule. Now the 4 comes down, we get 36 plus 6. So here we're going to get 3 times 3 times 9 plus 6 is 15. Plus 3, 36 and 6 is 42. So that's 9 times 15 is 135. 3 times 42 is 126. And really quickly, we'll just add them up. So we get 261. Right? So now we can put this all into the general form for our Taylor polynomial. So the 0th degree over 0 factorial, x minus 1, because 1 is our center, to the power 0. 9 over 1 factorial, x minus 1 to the 1. 45 over 2 factorial. Remember, 2 factorial is just 2. And then, what did we just work out? 261, was it? Yeah, 261 over 3 factorial. 3 factorial is 3 times 2 times 1. And 261 is a multiple of 3, so we could simplify this a little bit. Nothing really we can do with the 45 over 2. But we can divide 261 by 3. 87. So 87, so that cancels out a 3 down there, leaving 2 times 1. So 87 over 2. And there is our degree 3 Taylor polynomial centered around 1.